Hi everyone, today we're going to be talking about section 7.5, multiplying binomials. We've talked about polynomials before, we've talked about multiplying polynomials by monomials, and today we're going to talk about multiplying two binomials together. And we're going to talk about two different strategies to do that. Remember, bi meaning two, so these are two-termed polynomials. So a plus b times the quantity of c plus d. Now, what you're going to have is you're going to have numbers and variables in each of these binomials, and it's very similar to what we did yesterday. So it says use an area model to determine 2x plus 3 times the quantity of x plus 2. And our area model was the fact that area is found by taking the length times the width. So if we make one of these our length, and one of these our width, we will be able to calculate this. So if our length, and remember it doesn't matter which one you put where, so if our length is 2x plus 3, we're going to put a bar down where we see that plus sign, and our width is x plus 2. We're going to put a bar down right there. So what we need to do is we need to calculate the area of this shape. Now that shape is x tall and 2x wide. So for area, it's again length times width. So x times 2x, which becomes 2. We're multiplying x to the first and x to the first. That becomes x squared. We move on to the next shape, and that's the one right here, or you could go down, doesn't matter. It has a height of x and a length of 3. So x times 3 is 3x. The one below it in diagonal, right here, has a height of 2 and a width of x, 2x. So we've got 2 times 2x, which makes it 4x. And then the last one that we have has a height of 2, because that height is constant all the way over, and a width of 3. So we've got 2 times 3, which is 6. So the total area is what we want, and that comes from adding up all 4 of the squares. 2x squared plus 3x plus 4x plus 6. We can look for like terms. Here's a 3x to the first and a 4x to the first. This one is not a like term because it's an x squared. So we've got 2x squared. When we add like terms, we're counting how many there are. We have 3 x's here and 4 x's here. Altogether, we have 7 x's. Remember, that exponent doesn't change when we're adding and subtracting. I have no more like terms, so this is my final answer. Here's the next problem. Press pause in the video and see if you can try this yourself. Alright, I have mine set up. I made this my width and this my length, because length times width is the same thing as width times length. So 3x minus 1, 2x plus 2, there's 2 terms, so each side is split into 2. So if I look at this square, it has a height of 2x, or 3x, and a width of 2x. So to find the area of that yellow square, we have to take 3x times 2x. Multiply the coefficients, and add the exponents on the variables. We have a height of 3x here, and a width of 2. So when we multiply those, we get 6x. Down here we have a height of -1 and a width of 2x. So a negative times a positive is a negative. So negative 2x. And the last one we have a height of negative 2x and a width of 2. So negative 2. Our total area in our answer is when we add all of these boxes together. You can write this as plus a -2 for right now if you'd like, and plus a -2 again if you'd like, or you can leave it like that. Looking for like terms, positive 6x and negative 2x. Those combine to positive 4x. A minus 2 and bring down the 6x squared. And now it's in standard form. It's in descending order, x to the second, x to the first, x to the 0. Another way to do multiplication of binomials is through distribution. We talked in the last video about distributing one term into a parentheses, and now we have a binomial, so we have two terms. So you have to, in essence, do it twice. We need to multiply x times everything in the second parentheses, and then what we're going to do is go ahead and multiply 2 times everything in the second parentheses. And it's 2 because I look at the sign in front of it. So we've got x times x plus x times 5. Then we have 2 times x plus 2 times 5. 2 times the x, 2 times the 5. We're going to simplify these. X times x is x squared. Since we add our exponents, we have 5x and a 2x and 10. Then we're looking for like terms, and these two in the middle are the like terms. Our final answer is x squared plus 7x plus 10. It's up to you whether you decide which model you like. If you are very good at the area model, keep doing with that. If you like distribution, or if you've taken algebra and you like to FOIL, you can go ahead and do that as well. Pick whichever method that you like and try this problem. Pause the video now and check your answer when you're done. Alright, so I'm going to show you both answers and both ways of doing it. You have your area model and you have your distribution model. So if you look at both of these, you see that you get the exact same parts using both methods. And in fact, you get the exact same answer using both methods. So it just depends on which one you prefer and which one you're more comfortable with. And that's it for this video. Oh wait, I'm just kidding. We've got 2 more examples to do. So with this one, we have p minus 6 and p plus 6. What you're going to notice is there's a special thing that happens when you do this. P minus 6 and p plus 6. So p times p is p squared. P times 6 is 6p. Negative 6 times p is negative 6p. And negative 6 times positive 6 is negative 36. We have our 4 parts. If you want to do distribution, you absolutely can. Here's our 4 parts. And when we look for our like terms, we have a positive 6p and a negative 6p. When I add negative 6 and positive 6, I get 0. But we know that 0 times anything is 0. So this term will go away, and we're left with p squared minus 36. That's our answer. And the last type of problem you'll see looks like this. This is p minus 4 quantity squared. Just like if we had x squared means x times x. So if we have p minus 4 quantity squared, that means p minus 4 times the quantity of p minus 4. Now we have a binomial times a binomial, and we can do it one of 2 ways. We can set up our area model, or we can do distribution. P times p, p times negative 4, negative 4 times p, and negative 4 times a negative 4. And a negative times a negative becomes a positive. Area models will result in the exact same terms. We have like terms from our negative 4p and our negative 4p. Negative 4 minus 4 is negative 8. And Quinn will sing you that song if you need it. All right, that's it for this one. Ask for the homework or you can check your checklist.